University of Oklahoma Mewborn School of Petroleum and Geological Engineering is forging the path into the 21st century.
The University of Oklahoma has a history of excellence in energy education dating back to 1919, when it awarded its first degree in geological engineering. Over the last 90 years, more than 5,000 students have earned degrees in petroleum and geological engineering, which is more than any other university in the United States.
Over the past decade, the Mewborn School of Petroleum and Geological Engineering has placed more than 90% of their graduates in the oil and gas industry.
The Mewborn School of Petroleum and Geological Engineering is the leader in industry research and planning for future energy needs and drill sites. Here at the University of Oklahoma, students in petroleum engineering studies receive real-world, hands-on education.
The Rock Properties Lab offers students an opportunity to study and research the Earth's properties in an effort to seek out the most economic and ecologically sound places to drill.
This machine here is a nuclear magnetic resonance machine, which in short is pronounced NMR, and it's essentially a measure of the response of atomic nuclei to varying magnetic fields. And it provides a means to measure water saturated porosity, reservoir permeability, which is one of the most important parameters also. And the useful thing about this machine is you don't have to disturb the integrity of the rock. These students here are working on a barrier saturated core, so they're determining the parameters I mentioned earlier, the permeability and the water saturated porosity on a barrier saturated core.
My team back here is working on the Fourier Transform Infrared Spectroscope. It stands for FTIR. And they're just working on an experiment back here and trying to determine the exact clay mineralogy of the shale samples. We have to know a lot about the exact clay mineralogy and what types of clays are in our shale samples. That way we can determine other things such as, like the swelling properties of the clays and the bound and free water.
This is a combination of velocity, resistivity and mechanical testing static moduli. What it does actually help us gather specific petrophysical properties of the rock. The resistivity measurement help us get the water saturation, and it also help us get the true value of the resistivity in the rock. It helps us definitely understand what's going on in the ground.
Me and my team here will be monitoring the acoustic emission events, which will be creating artificially by pumping the fluid into sample, and we induce the hydraulic fractures within the sample. One of the main reasons which propelled me to come to the University of Oklahoma is the expertise and well-renowned professors which we have here, and the laboratory facilities which we have here, which supports my academic studies.
The Well Construction Technology Center at the University of Oklahoma is a state-of-the-art facility for conducting fluids-related research for the oil and gas industry. Over the past 17 years, it has helped develop innovative technologies that have improved the efficiency and economic viability of drilling, completion, and production operations.
We have field equipment, we have field-size mixing tanks and blenders, and we also have different configurations of tubings. Like for example, in the oil industry, we have different configurations of tubing, straight tubing, extension channels, and coil tubing. And most of the times, in conventional drilling, we use drill pipes, and it has to be affixed to each other before sending it down the wellbore. But as you see over here, coil tubing, you just get the coil tubing reel and then send it into the wellbore. It saves a lot of rig time, and it saves us money, and there's no leakage compared to conventional drilling.
The gelation of waxy crudes and restart of shut-in is a project where students are researching ways to prevent loss of produced fluids and to create flow assurance after a time of underwater pipeline shutdown.
The objective is to investigate wax deposition in subsea conditions and how pressure affects gel strength and restart conditions of our pipelines. This is what happens after a while when the pipe has been shut in. Because of the cooling effect that results from the pipe being shut in, the viscosity of the oil increases, and then when we get to a wax appearance temperature, wax starts to form. And if this goes on for a relatively long period of time, we have gelation, which is what this wax embodies. And then what we see is we're not going to be able to flow the pipe. The importance of this experiment is such that it helps us to design and select appropriate paraffin disposal techniques for paraffin deposits in gel pipes, and also to maintain flow assurance in the pipes.
The Mewborn School of Petroleum and Geological Engineering is one of only 4 locations in the world that has a nano-scanning electron microscope laboratory.
You're in the Devon Energy Nano Imaging Center, and what we do in this center is we study the microstructure of gas shells, and we do that using a scanning electron microscope. And with the scanning electron microscope, we're able to image the structure of these shells using an electron beam, and we're able to image features that are so small they're about 50,000 times smaller than the width of a human hair. And he's working with what's called energy dispersive spectroscopy, so he's investigating the elemental composition of some of these gas shells over there. Basically, a lot of models and simulations are based off what the structure of these things are. And you have to know the right parameters to plug into these models and simulation. And that's what we're basically doing over here, is coming up with what are your pore sizes, how connected are the pores, and things of that nature.
One of the crown jewels of the Mewborn School of Petroleum and Geological Engineering is the Deepwater Oil Well Drilling Simulator. This digital drilling simulator offers a real-world research and training facility for the students in the world of offshore drilling technology.
It simulates an offshore drilling rig in the Gulf of Mexico, ultra-deep water drilling ship, and semi-submersible rig that can drill in water depths of up to 12,000 feet. And up to 37,000 feet drilling depth, total drilling depth. And this was donated by National Oilwell Varco. Its primary use is training to help eliminate costs where safety and environmental hazards were before. It uses automatic roughneck. It eliminates the use of a roughneck on the floor, eliminates safety hazards. And also it has state-of-the-art technology to help eliminate environmental hazards that have impacted in the past. The Petroleum Engineering program at OU is one of the best in the aspects of the best simulators, the best labs, and all that. And of course, this drilling simulator is one of the only ones in the world, so that is a big encouragement to Temple University, Oklahoma.
From hands-on summer internships to everyday student life, students at the Mewborn School of Petroleum and Geological Engineering experience the great taste of college life in a great college town. Educating tomorrow's engineers, placing students in the world's energy corporations, and creating research that benefits the energy needs for everyone are the reasons why the Mewborn School of Petroleum and Geological Engineering is forging the path into the 21st century.